Hi, this is Sun and I'm the Principal and Director of Sky Academy, and up until now what we've been doing is we've been working through functions and relations and the topic called functions and relations, and in the last episode we looked at some common types of functions that you might encounter from quadratics to cubics to circles to exponentials, and one that we will encounter in this particular chapter more likely than not is rectangular hyperbola. And let me just go through the general form of a rectangular hyperbola. You might recognize the rectangular hyperbola as looking like this: y is equal to k over x, right? And that's actually quite a simplistic form, and y equals to k over x, and it looks like this, so it spans across two quadrants, right? And it approaches a value or a line, a vertical line called an asymptote, where the function approaches but does not actually touch, right? It approaches as it gets really bigger from the right, and it gets really small as you approach it from the left. And sometimes you'll see that in reverse, right? It also has what we call a horizontal asymptote, or a line that the curve gets closer and closer towards without actually crossing or touching, right? And in this case, a rectangular hyperbola will have both a vertical and a horizontal asymptote. And while this is the form that you might recognize a rectangular hyperbola in, y is equal to k over x, sometimes you might see it in a more complex form as y equals to ax plus b over cx plus d. So one algebraic expression over another algebraic expression that's a binomial in form, or monomial in form. So let's have a look at how you would go about sketching a rectangular hyperbola. So there is a 5-step method that I like to employ that helps us to graph a rectangular hyperbola, and that is this. Number one, find any x-intercepts, alright, and you do that by letting y equal 0. Find any y-intercepts, and you do that by letting x equals to 0. Find horizontal asymptotes, and you do that by letting x approach positive infinity and letting x approach negative infinity, and see what happens. See where the graph, where the curve tends towards going towards equaling. Step 4, you find the vertical asymptotes, and you do this by letting the bottom half equal to 0, because that's the one value that the bottom, or the denominator, cannot equal. It can't equal 0. So we want to test things out by making the denominator equal to 0, because that's where the function will be undefined. That's where your vertical asymptote will be. And then finally, determine the quadrants of your function. Okay, so let me give you a quick example right here. Y equals to 5 over x minus 2. Okay, y is equal to 5 over x minus 2. See how it fits that form? Now in this particular case, a would be equal to 0. Okay, that would allow b to equal to 5, and it does fit the form of a rectangular hyperbola. So let's have a look at how you would go about solving this. First, find any x-intercepts, okay, by letting y equal to 0. Now, there are no x-intercepts because y cannot equal to 0 because your top number is 5, okay? And that would be a hint, because y equals to 0 is more likely than not, because it can't equal 0, it's more likely than not it's going to be a horizontal asymptote. Alright, so step 1, x-intercepts, none. Okay. Step 2. Find any y-intercepts. Y-intercepts will be when x equals to 0, and basically your x-intercept will be y equals to 5 on 0 minus 2, which is equal to negative 5 on 2, right? So your y-intercept will be at 0 minus 5 on 2. That's where your y-intercept will be. Your horizontal asymptote, step 3, will happen, and you examine this by letting x approach infinity, or positive infinity, or go towards a really, really, really big positive value. And what happens is, as this gets really, really, really big, y will tend towards, well, what's a really, really big number? What's 5 over a really, really, really big number? It'll get closer and closer to 0. So it'll approach 0, and it'll approach 0 as a positive number approaches 0. See how this is positive and this is positive as x is positive infinity? So it's going to approach 0 from above, right? And I'll explain what that means a little bit later when we graph it. Then we examine what happens when x approaches negative infinity. And as x approaches negative infinity, y approaches also 0, but in this situation it's a positive number over a negative number, right, because it's negative infinity, positive number over a negative number, which will approach 0, but from the bottom up, alright, so it's approaching 0 from below. So we put a little minus sign there, right, to say that it's approaching 0 from below. And then step 4, you find the vertical asymptotes. And the vertical asymptote is going to be when the bottom, okay, equals to 0, alright, then you have the vertical asymptote. So when x approaches 2, right, because when x approaches 2, that's when the bottom is going to approach 0. When x approaches 2 from above, from a positive number going down, then you've got a positive 5 over another positive number. So y approaches positive infinity, okay, because you've got a positive number over a positive number, so it's y is going to approach positive infinity. And when x is approaching 2 from below, y will approach negative infinity, because as a negative number gets closer and closer, it's going to be a negative, so a positive number over a negative number as it approaches 0, so it's going to approach negative infinity. Okay. So there are your 4 steps, and then basically what you do is you work out your quadrants. Step 5. And I'll do that in a second. Okay? Now, does that make sense? They're the 5 steps that you've employed. In the next section, what we're going to do is I'm going to bring up a number plane, and we're going to graph that function and see what it looks like. Alright, so I'll see you soon.